Give it a few minutes, let the guys kind of wander in before I start. Guess it's kind of awkward time. It's like 1:10 in the afternoon in Eastern Standard Time, and might be in the middle of the night for the guys, you guys. So what time is it in Europe? 7 o'clock, but it's just right after dinner. So hopefully we get a few of those guys in. People are coming in. Let's give it a few more minutes. Okay, 4 people. Guess that's good enough. All right. So first things first. This is what was in the Musumi package. So the rods left the box. So I posted the pictures to them, and then hopefully they'll replace them. So that should be okay. I have to start to return the carriages. So basically, they're the wrong ones. I had to get the adjustable ones. They're gonna cross up those to me. So hopefully it's good. Yeah, there's a reason why why we wear the Cade T-shirt. I'll get into that in a second. Um, Let's printing another figurine over there. So this was the one that it's the size of my head. This is one of the ones I printed off with the transparent orange PLA. Looks pretty good. 375% from the original size, and then this one. So this one's slightly bigger. Cat, Japanese cat. So these two together was one spool. So I guess I'm just using up all the PLA that I have in stock, so I don't want to deal with it. So that's kind. This is so I can show you. So this is the normal size, and this is 375. So yeah, I think that's about the limit on the printer right now. It's 375%. We'll go up to way more than that when we get to the 420. Happy Sunday, happy Father's Day. My godson's coming over later, so we're just gonna basically do a quick stream, update you guys on some of the stuff, and then I'm thinking about proposing the next monthly design challenge. I think I got a good idea, and I think everybody will enjoy it. So let's just get right into it. So um, let's switch to display capture, and let's get right into it. So I did some layout work this week, and this is pretty much the a very rough layout of the printer right now. Let me bring back the other axes. So there you go. So basically, that's gonna be the layout of the printer. Um, I think you see get a good view. So basically, depth and width is gonna be 560. So it's 500 on the cross beam plus 30 on either side. So this is the non-enclosed version. So the non-enclosed version is going to be 560 by 560 deep, and the verticals here are 750. So from the tip of here to the bottom of that is 750. So let me check that axis off so we can see things a little better. Okay. The bottom is going to have these four pieces for the rigidity of the bottom. So basically, again, these are using M8 by 40s to kind of tie the bottom legs together, and also provide a mounting point for the Z motors. So the plan is that there's going to be Z motors on this side and Z motor on this side. That's going to elevate the bed from two ends, from the left and the right, with 12 millimeter watts. That's being worked on right now, but I just made sure that I got at least 450 travel for the platform to the bottom of this vertical here. And also the bottom here gives you space to put the power supply and the controller and all the other stuff on the bottom here. We'll work out some cross beams that allows you to do the mounting later on, but right now this is kind of like it's going to be kind of open at the bottom for all your accessories and stuff like that. Let's see. So we talked about we talked way too much about the XY gantries. I'm going to skip that. There's going to be this cross beam here and this cross beam on this side, and that's going to provide the upper Z rod mount and the end stop switches for the Z travel. So those two cross beams are on left and right because the Z driven from both ends, left and right, and then the front and back is purposely left open so that basically when you're using a printer, this is going to be the view, and you have an unobstructed access to the print bed. The back obviously is also clear, so all the mechanics for the movement is going to be on the left and right side of the printer, and the front and back is clear. So this is a 420 420 by 420 bed mounted on 2020 extrusions. So the idea is that the 2020 should give it the rigidity it needs to stay flat against the 2020, and it gives something for the motor to the lead screw to move, so that, like you said, of just trying to move the plate and have the printed part. It's basically going to have an adapter that's going to adapt the 2020 extrusion to 12 millimeter bushings to go up and down on the Z axis. So again, that is being worked on, but basically I was just making sure that we have enough clearance for if I bring this up here. So there's enough clearance here for the E3D to I could still kind of go up another 10 mil here, but there's more than enough clearance for whatever hot end you guys are going to end up using. and that still provides enough travel here for majority of what we're going to be doing. So this is kind of like the as stable as we're going to get in terms of the dimensions right now. This is we're going to go with this unless something really drastic happens and then we need to change this. But this is what we're going to go with as the current work in progress. And then I'm basically the idea now is I'm moving on to the Z, like I said last time, and I've been working on the lower motor mounts and figuring out whether or not we need a 500 millimeter lead screw because the problem with the 500 millimeter lead screw is that it protrudes a little past this crossbeam. So I'm kind of leery on that because we really only need it down to here. We don't need it all the way up to here. The smooth rods we need to go all the way up to the crossbeam, but the actual driven lead screw probably get away 420 or 450 to push the platform up that high. So we'll kind of work on that because a 500 millimeter lead screw compared to a 420, I think it's like a $10 difference. But that's not really the problem. The problem is that once you get to 500, shipping it to you will like Robotech will want to ship it to you by EMS. I think you could still get 420 or 450, and they'll kind of package it in a way that they don't have to ship it in EMS. So it's a shipping cost issue. So I wanted to kind of keep it to 450 if we can, if and then make it an optional for 500 if we need to go to 500. So I want to kind of take some so this is pretty much done. So I want to kind of talk a little bit about the heat bed itself. So basically, I'll bring up the bed frame here for a second. So this is the bed frame. Basically, the idea is that this is a let me just highlight it. So this is a 420 by 420. Is 17.5 inch by 17.5 inch, which is 422 and a half by 422 and a half millimeter. So the idea is that we'll get it at that 422 and a half millimeter, and you will take it to either you keep it the way it is, or you take it to machine shop and have them kind of round off the edges so that it gives a smooth edge. So what I did here was I made a 1 millimeter fillet all around all the edges, and then I'm probably going to get a machine shop to bring it down to 420 so that it's a nice smooth finish on all the sides. This design shows the countersunk screws. I'm playing around with another idea right now, but I'll show this one anyway. It's just a countersunk screw that's going to tie into a T-nut on the frame. So again, here is that we're going to be using a M6 by 30 to tie these two pieces together. So again, that gives the rigidity that we're used to with the 3030. This is going to be the M6 and the M8, but M30 goes in about 15 millimeter engagement there. So that should give it plenty of strength there. So these four pieces these four pieces are 400. So with the 20 extra on the edge, that gives you 420. So it's like 400 extrusion, four pieces bolted together gives you 420 square. Then on the bottom here, that gives an internal cavity of 400. We'll probably end up with getting like a 380-ish silicon heater for this. I think they sell 360, 380, so we're probably going to end up getting a 380 silicon heater in here on the bottom here, so that it'll be nice and enclosed underneath there. And this is basically the basic bed design. I'm still missing a few screw holes on the bottom. One is for the mister, and one is for the grounding. So basically the idea is that we want to ground that aluminum plate to the live ground on your power supply, so that if anything happens, it basically will short out and blow the fuse on the trip the breaker or whatever it is, instead of killing you when you're using the live voltage for the for the silicon heater. So those two holes are still kind of we're debating on which way we're gonna put it. We still have to figure that out. So it's not so much a thermal fuse. Basically, what happened is that if because for this size bed, even 24 volts would take a long time to heat up. So the idea is to use a live voltage, like 110 or 220 silicon heater, and those silicon heater, when they fail, they basically fail open. So basically, it'll flood it might short on the aluminum plate. So the idea is that you would ground that so that if it does short, it will trip the breaker or blow the fuse or whatever it is on your or trip the breaker on your power bar, so that it would automatically shut down. If you don't ground it, basically, then that live voltage is sitting there on the plate, and then you touch it, you basically get shocked, right? So there's a standard practice, and then basically you just need to kind of put a screw there with a ground, and everything will be fine. This was also reflected here is a 6.35 millimeter, so that's a 1/4 inch plate. If we were using a 2020 outside frame, I think we'd get away with 6 millimeter, like a 1/4 inch, instead of a 9 mil, which is 3/8. I didn't want to go 3/8 because right now the weight difference between a 1/4 and 3/8, I think 1/4 is 7.5 pounds, and it's 2 pounds more to go to 3/8. So even at 7 pounds, it's quite heavy to move this platform. And I don't want to go to 9 pounds. By the time it's like end of 9 pounds, like 9.7 pounds. So that's almost 10 pounds that you have to move on the Z axis. So if we get away with, we'll see how it goes on the alpha test. If you get away with using just a 6 mil plate, then we'll go with the 6 mil. Because also the bigger plate also requires more heating too. So we sort of kind of want to keep it down to 6 mil if we could get away with it. So after I did this, I was asking on chat about thermal expansion, because basically when this plate is heated, it's going to want to expand. And when you have it tied down on 4 points, when it wants to expand and it cannot overcome the constraint, it's basically going to buckle upwards or buckle downward, whichever it is. But in this case, because we are constraining on the bottom, it's going to buckle upward. So you're going to have a convex print surface. How much of that actually going to matter? We're going to have to test it, but at this size, at 420 by 420, I think I forgot the guy's name now, but one of the guys helped me out on chat. He's an engineer. And he looked at it. It's going to go from 420 to roughly 421 and a half, 422. So that's a 2 mil expansion on it. Then when you have a 3 mil or 4 mil screw, 2 mil expansion is quite a bit. So I wanted to see if it will create a problem. So one of the ideas I sort of have to be throwing around is this idea of a bed standoff. So this is what it looks like. So the idea is, let me see if I can get rid of these two. The idea is that we have a high precision shim that sits on the extrusion, and that's a M5 bolt that will tie into the T-nut. That creates a stationary post, if you want to call it that. And on that post, what we're going to do is actually put 2 O-rings. The 2 O-rings is going to bring the diameter of this post to 10 millimeter. And because these O-rings are compressible, but they still kind of is still pretty strong, and you could actually keep the plate in place. The idea is that we will go and have a. Let me bring this up. Move this up a little so I can show you. Okay, there you go. So the idea is that we have a 10 millimeter hole on the bottom side of the plate, a blind hole. So the hole doesn't go all the way through the plate. It's a blind hole that goes up 2 millimeter. And the idea is that we drop this plate onto this post, and the O-ring is going to be 10 millimeters. It's going to give a tight fit inside the blind hole. But when the plate expands, it will compress on one side or the other of like a few sides of the actual O-ring, and allow it a slight movement. Because if you think about it, if the whole plate expands equally, the 2 millimeter on all sides is going to be a 1 millimeter movement. This is a 2 millimeter um, outside the C, they call it CS. The O-ring diameter is 2 millimeter, so it would squeeze the the direction that it wants to move. So it will kind of take up the allow it to move, and then also like still maintain the precision. I have to kind of test the idea whether or not this will work. Um, it sounds plausible, but we have to kind of play with it. So what I'm actually going to do is actually take a scrap piece of uh, metal, build this post, and put the post on there, and then see if I get it to sort of stay stationary in a way that is not going to affect the print, but yet allow me to like a 1 millimeter movement back and forth on the post itself. So what the idea is going to be is that we're going to have 4 of these posts where the screws normally is, and then it allows you to just basically drop the plate onto these these posts, and the top of these bolts is basically going to sit on the top of that hole. Um, so there's no O-ring on top to kind of wiggle. It's basically going to be metal contact. It's going to drop right onto that post. Um, it it's a wild idea, and so right now, if the proof of concept works out, what we're going to do is actually, instead of using a bolt here, I'm going to get a piece that's going to basically let me take these O-rings away. So basically, imagine this piece and the spacer is all one piece. So if I get that one piece CNC machine as one part that screws onto the T-nut, then basically it's a repeatable exercise. You would just basically put it there. It's gonna have like a slight collar to capture the O-rings, and then basically this blind hole will be an exact fit to those O-rings. So, like I said, the first is to kind of make sure that this O-ring is compressible. It gives us the 1 millimeter movement that we need. The other one is, once we do that, is to see how much it costs to kind of machine a part that's gonna do this job, or are we gonna be able to get away with this? One of the problems is that the M5 bolt is 8.5 millimeter OD. The O-ring is 8 millimeter ID. So I'm already stretching that O-ring onto the M5 bolt. So whether that takes away some of the compressibility of the O-ring, and also whether that's going to increase the diameter of the overall post once I do that, so that it won't fit inside the 10 millimeter blind hole. So all of that is kind of like up in the air right now. But I just came up with this idea this morning. I thought maybe we could kind of investigate this a little bit further. Worst case is if we go back to the countersunk holes on the top, but the countersunk hole on the top, it doesn't give us the expandability, the expansion, for the thermal expansion of the board, and also there's going to be then, instead of a perfect smooth surface on top, you're going to have 4 blind holes that you kind of have to avoid when you're printing. So that's one of the things that I was thinking is of this solution, is that it's a blind hole at the bottom. You won't have any problems with the top. The top will be perfectly smooth for your print surface. We have to see where we go from there. It really one of those, like, we gotta try to see if it actually works kind of situation. So that's pretty much the update in terms of the cube. I mean, that from afar, that's basically what it's going to look like. It's going to be a. I know some people are going to tell me it's not a cube. Because right now it's kind of like a high rise because it's taller than wide and deep. So it's no longer a cube, but the internal volume is cubed. So I guess that you gotta get away with it. And I'm kind of calling it Haribo 420 anyway. So it'd be 420 cubed inside for the print volume. Um, the I know I'm showing the non-enclosed version, but like I mentioned last time, is that all you would have to do is replace this profile with a 6060. That'll give you the outer two rails for your enclosure. So it doesn't really affect changes. Doesn't really affect the design of the printer. You just have to buy the correct one. If you want enclosure, you buy 6060 for the four verticals. If you want non-enclosure, which is what I'm building, then you do a 3030 on the outside. You can also do a hybrid, so you can kind of get you could get all four of them, but then like only contain the three sides and not the top and bottom and the front to kind of cut down on drafts, and then you can put them and then or dust, and then you kind of like put it in the corner, be fine. A lot of us don't really need an enclosure, so I guess that gives you the option. The other nice thing is that all of these four on the bottom, and these six on top, so that gives you 10 total 10. Those 10 pieces are all 500 millimeter long, so you don't have this. You don't have the thing like with the Haribo 3030 where you have three different lengths. All 10 of these is going to be 500 millimeter cross beams, and then you have the four vertical. So in terms of the bomb, the consuming uh, the extrusion count is down, but um, the kind of T nuts you need is going to be different because you're going to need 3 millimeter T nuts for the 3030 and 4 millimeter and 5 millimeter for the 2020 if you do it this way. So what I'm going to do is for those, because I know that we don't want to be buying like a whole bag of 100 just for 6 or 7 that you need. Um, I'll probably end up packaging them and selling them as packs, or hardware packs that you could buy. That way you don't have to buy a whole 100 just to get 6. So we gotta go from there. Um, and then the 2020, because it uses a stagger pattern. Um, Also, it is 400 by 4. So you just buy. It doesn't really matter which how you buy it. You just basically buy 400 by 4. I'm not gonna gone with um, you know, 360 by 2 and 420 by 2, and then you kind of bolt them like with the short inside and stuff like that. Then you end up with maybe a slightly stronger frame because the way it works, like you're enclosing it, but then you end up buying two different sizes. So it really depends. I mean, I'll try it this way, see if it's the stagger pattern works. I can show you what the stagger pattern looks like. Um, so the idea is that this ends at the end of here, and then we are using a kind of like a butt. I think they call it a butt joint against the other one, so that is it rotates in the counterclockwise, and basically all the bolts are coming from either side of the extrusion. So um, that should work pretty well because it does. This bolt will prevent this one from rotating, and this one will prevent this one from rotating, and so on. The next one down the line prevents it from rotating, and because we're going to be somehow bolting it together to the bed, it should be pretty good. If not, I mean, I would just add a few corner brackets on the bottom for alignment purposes. It should be fine. So I'm not going to worry too much about that. It's 2020. The way it flexes is very low anyway, so not really going to worry too much about it. 400, I think, is about with the limit. I would push to 2020. You get longer, but then like it starts kind of getting all funky. I don't like using it that long, so just kind of throwing it out there. So this is kind of like again, like I said, this is the picture we're gonna go with. So let's just go with that. And we talked about that. What else do we want to cover? I think that's it. I mean, I apologize. I haven't really been working too much on it. mainly because I've been kind of going around trying to find different things to solve that bed problem. So hopefully, do you need to allow for the bed frame expanding? So if if the um, if the bed is directly bolted to the bed frame, then the bed frame will prevent the bed from expanding, so that it would end up buckling or sort of slightly convex. If we use the post because it's also going to be kind of isolated by the O-rings, it will allow the expansion of either one. So you don't really need to allow like the bed frame should not get hot from the like the thermic the thermal conductiveness from between the post and the bed frame and the heated surface is very low. So then I don't think it's going to heat up enough to expand that extrusion frame. So right now, I don't think I need to allow for the expansion of the bed frame. That might change when we build the printer. So I mean, if you go out there and look at it, a lot of the guys that do large format printers, they don't seem to be really concerned about this idea, like this issue. So maybe it's just an issue that comes up rarely, and I'm just trying to solve a non-existing problem. I don't know yet. So maybe we kind of go, kind of wing it and see if it is an issue or not before we try to solve it. So that's why I said, like, I'll probably end up going with the countersunk for the first iteration, and then if it works out okay, then problem's not there. We don't have to deal with it. So I guess I will. I'll wait till I actually run into that problem before I try to solve it. Okay, so let's go shopping and so on. Let me find it. I apologize. I had his. I can never pronounce his name, so let me just find it. Here, this is the one. So, it was on the. How am I do this? Okay, so let's do this. So in the Haribo 3030 channel, 8:15 or so, we had a discussion this morning. So if you want to kind of scroll back and read what we came up with so far, we can kind of go from there because I asked him to do it from room temperature to 125. So the, um, the 125 is kind of the upper end of the bed temps, and I think his if I go a little further back, uh, I gotta find it, but basically, I think what we found was, like I said, 421.6 or something like that. So the 1.6 millimeter expansion to 125 millimeter, 125 C, is that really going to be a big diff? I don't know. So we kind of have to play around with that. Kind of wanted to share a channel with you guys. I really like this channel. I've been watching a bit of it. So um, basically is uh, talks about different Japanese cultures, different Japanese technologies, and historical things. Whenever I have some time, I like to watch one or two of these YouTube videos. It came in really handy for me, so I learned a lot from them. So hopefully, you guys find it useful as well. The other one is eSun had Philbin SCA had a sale on eSun, like a flash sale, and most of it is ABS plus and PLA plus. Um, I ended up getting more rolls, but at $24.95 snow pesos is actually not too bad. I mean, I was able to get 6 rolls free ship for like $150. So you can't go wrong with this if you find the color you want. $24.95. Okay. Yeah, Donald. Like he did the math and everything on because I found the coefficient of expansion for the mixed six plate. So he plugged that into the formula and then did the delta, the C change between I think 25 and 125 C. Then did all the funky math and he came up with that 421. So I think 421 is kind of like on the edge of we shouldn't care about it. So I'm kind of going with I don't care. But the problem is I still want to kind of go with that post idea because if I get it to work, it'll give me a blind hole and then we have a simple surface on top. So I want to still kind of go down that road with that idea, but at least then I know I don't have to maybe don't have to use O-ring. I can just go right with a 8.5 millimeter hole, and then the bed drops right onto the post, and then we're done with it. Right. So because what I said before was if I drop it on the post, that should allow a little bit of lateral movement, and then but prevents the Z movement. So the lateral movement is what we want, but the Z movement is not. So and if we get a quick release for the silicon heater, you can actually even take it out, put a new one in, and then plug it in and print some more. So um, maybe that's an idea, right? So um, so for guys who um, for the guys who haven't been around the chat, one of the things that we started was called a monthly design co-op channel. So basically, the idea is we have the weekly printing challenge. So weekly printing challenge is that we pick a challenging print that requires some tuning or some manipulation or what of settings or whatever, and then we'll kind of make it a weekly activity. So um, there was some talk about we sort of running out of things to print, and also we want to expand that activity. So there was I threw out the idea about doing a design challenge, and I think because the design takes a little longer, so we decided to on a monthly design co-op. So every month we'll pick a topic, and we'll share Fusion 360. So that's the default. You could use other things, but the default is that we'll share a Fusion 360 project workspace, and you go and start your own design. And basically, that allows other people to see your design, and we kind of look at each other's and iterate the idea, and we kind of learn from each other and solve each other's issues. And then once we get a good design going, then maybe that could feed into the weekly print challenges, because then it's something that we kind of evolve over time. Right now, we just started the channel. We kind of not have a lot of good ideas right now. There was a few. I think one was talking about industrial lighting, pen lighting, stuff like that. So one of the things I was thinking would be really interesting is a lot of us grew up in arcades, say arcades, and I backed Kickstarter Piecade, which is where this shirt came from. Basically, is a miniaturized arcade machine. So it is rather expensive to buy one, and then because we all have our sort of experience with printing and with like electronics and so on, I thought it'd be kind of great to design a slightly smaller one we could print on our own. Like we could print most of these pieces anyway. So the idea is that I'm proposing the idea to be a design challenge to do a arcade machine that will be fully playable with all the electronics and stuff like that, and we could kind of start a bomb and have like a open source project that we could kind of share with the rest, right? So um, one of the things I found on AliExpress, kind of just jump right into it, right? One of the things I found on AliExpress is this thing called a Pandora box. So Pandora box 4S is the latest one. Um, what this is kind of like um, a all-in-one board. I don't know if I have a picture of it, but basically the idea is that this is a standard jammer board that allows you to pick from like 680 games. They have like a menu of all the different games. So basically the idea is that this is the jammer board inside. This board is the one that's inside this casing here. So basically it has HDMI VGA out and audio out, and you basically go through a menu system. So I don't know if I should show the menu system. And you pick the game you want to play, and then the jammer. I'll put the link. I'm trying to scroll past all this. See, they're all different color for the case, but we don't actually use the case. We probably end up ripping it out of the case anyway and using it with or without it. So, see here like this. Like basically, you do your settings, and then you go and you pick the game you want to play. So, I thought this would be a little bit more elegant solution than using Picade. Um, or the not the Picade, the emulation, because this this has all the stuff you need, has the interface. Um, the nice thing about the Jammer, just in case, so I'll give you an introduction on Jammer interface. The Jammer interface basically, um, yeah, it's like main, but let me kind of go. So here you can see they give you a pinout for the Jammer interface. So Jammer is a standard edge connector interface that determines things like the speaker, the joystick movements, and the buttons and stuff like that. And if you build a cabinet with the Jammer interface, and later on in the Street Fighter added a kick harness, if you built your cabinet with the Jammer interface and a kick harness, you pretty much should go buy any arcade board, plug it in, and you could play on the cabinet. So it's slightly better solution, I think, than using a Pi and using an emulator and MAME, because then you end up with you kind of have to do all the work. And for I think this is like $50. For $50, you really can't go wrong with this. It comes with the I think I saw it. Yeah, so it comes with the Jammer interface and the stickers and the manual. So all you have to do is wire up the harness to your joystick controls, and then off you go. You're done. The side has, like I said, has a VGA and HDMI. You can hook up a set of speakers to it. You could pay all kind of like that's part of the design, right? Is how do we design the cabinet to have integrated speakers and all that other jazz, right? There could be a design challenge for the coin operation, because the coin operation basically is it's just a micro switch that basically you put a coin in and it'll activate the micro switch to put coins in. So this is a very expandable design challenge. So that's what I'm kind of proposing it. So I think this one, yeah. So that one roughly, I think, let's say we go with the 4S. So $55 for the Pandora S 4S. So that's the base motherboard you're gonna need, plus $30 for a 7-inch screen. So the 7-inch screen, the reason I picked this one is because it's a low power one, and it has VGA and HDMI input, so you can use either or. When I built the when I built one before is I use a VGA between the main board and the screen. Then I use the HDMI here as input for an outside source. So if I wanted to use it to kind of as an external display, this HDMI port is outward facing. The other thing is the HDMI output on the main board. I would have that output as well. So basically, if I wanted to take this thing to a friend's house and play on the big screen, the controls still work, but the output is to the big screen. So instead of using HDMI, because most TVs don't have VGA, so if you just use the VGA interface between your Pandora box and this, then that leaves your two HDMI free for other things that you want to do. So it comes in that's a good design, I think. So we'll go with that if you wanted to have the flexibility, or if you say, you know what, I don't really care. Your other choice is you go with have the HDMI out from the main board going outside, and then have the HDMI input on the display port going outside, then you use a loop cable to loop the two. And then if you ever need to use one or the other, you just take off the loop cable and then you plug into your where you need to go. So there's a lot of different ways you could do it, but I just don't like having to carry around a loop cable. The HDMI works fine. It comes with a remote to switch the input, so this one works really well for $30 odd. So we're looking at what, 80 odd dollars, $90 for the main board and the display. Then you start getting into things like the joystick controls. It's not expensive at all. Like you could buy a whole set like this. Like this is obviously not the Japanese. It's a Japanese type, right? So that gives you um, the buttons and the joystick and the harness you need. And this one's a little nicer. It comes with a USB interface as well. So if you get creative with your wiring and you have the output for you split the output between the main board and this USB interface, you can actually use this as the input to your computer or to like a PlayStation or something like that. That allows you to reuse the joystick for other things. So for $15 with the joystick and the buttons, yeah, you really can't even go wrong with this either. So now we're up to like just over $100 for everything you need to build it except the case. So I'm thinking it is reasonable for a design challenge. Spend $100, build an arcade machine, and you can play all the games that you grew up with, and you can use it for other things too. So um, I don't know. It's up to you guys, but I'm thinking this is a pretty good idea. We can go with this and sorry, something in my eye. Yeah, that's just like if you guys want to kind of go with this, I'll post all the links um, for the different items that we need to buy, and the we could kind of come up with the step files for the different items or different components, and then we could kind of lay it out and see if we can actually print a arcade machine out of for and play all the games that we used to play. So, I mean, we could buy the whole thing for 180, but again, like they have been out of stock for a while. So, and basically they use I think they use Immu Station if I remember correctly. There's a little nicer. I mean, they have laser cut parts and stuff like that, but I think uh, yeah, we loaded with Picade software. Yeah, so um, you know, I think we could probably build it for less. That's basically what I'm saying. Is that we could print all the panels and stuff like that ourselves. Um, I'll post up the links and see if you guys would like that. Well, this is all in one, right? This comes with um, the oh, this one a little bit nicer. It comes with the power supply, the actual coin door, um, all the joystick and switches and speakers and fans and the keys for $101. So there's different bundles. Our other choice, is really to just buy one of these doohickeys, right? But again, the problem with these is that it's roughly $200 by the time you add the shipping and the cost. It's about $200, and the actual Pandora's box is built into the case itself, but you don't get a display. So it'd be twice as much money, and you don't get a display, but you get two players. So there's different ways you could do it. I don't know how you guys want to handle it, but it's just something I want to kind of build, and I thought it would be interesting for you guys as well. Um, let's see. I think that's it for me. I mean, like, it's again, like, I'm not the type to go 4 hours, like, he went 4.5 hours last time on his stream, and I just like to keep it within the hour. I can't talk forever, and you guys can get bored easily. So, um, any questions, discussion, issues? I guess I should say I hope to get a C out of 10 for review soon. Somebody listening? 8 people. Yeah, that could be why slow. So the one I was looking at before was on Japanology was hey Donald, small factories. Let me see if I can find it. Talk about small factories and yeah, small factories in Japan. Um, it's actually pretty cool. Like they show you the different ways they're making plates and stuff like that. Like this is just spinning plates and all that. So I find it very interesting. So hopefully you guys can check it out and subscribe there. Um, subscribe to me too. Right? So okay, I think that's it. I'm gonna call it. I'm gonna call it and stop the stream. I'll catch you guys in the chat, and we go from there. Okay. Yeah.